Today I want to talk about tree traversal, and as you know, tree traversal is basically moving on a tree between nodes through different edges. And if any of this terminologies does not make sense to you, let me know in the comment section and I'd be happy to explain them in more detail. In an interview setting, there are three main approaches that we can do tree traversal with. One is pre-order, the other one is in order, and the last one is post order. And each of them can be implemented either iteratively or recursively. In today's video, I will be talking about the pre-order approach, and I'll talk about post order and in order on separate videos later. There are two things one need to know about pre-order approach. One is that it's a top to bottom approach, meaning that if this is your root, you start from the root and you move toward the leaves that are somewhere at the bottom of the tree. And the second thing is that the procedure is that you start from the root, you cover left subtree, and then you cover right subtree. It means that if this is your root and there exists a left subtree, I'm going to call it left subtree, and I'm going to call this right subtree. So you need to cover the whole thing on the left subtree before moving to the right subtree and cover that. And assume that there is no left subtree here. And then we have right subtree, right? But the right subtree has two parts. Let me make it clear. The right subtree has a left subtree of its own and a right subtree of its own. When you come here, you cover this node and then you go and cover the whole left subtree of this node before moving to the right subtree of this node. I hope it's clear, but we'll do some examples. In the first example, you're given this tree, as you can see here. Note that in an interview setting, you don't get the actual shape of a tree schematic. You get a list like this. And generally it's leveled, like it starts from level 1, the root level, level 2, and then for level 2 it starts from left to right, and so on and so forth. And they ask you to process or traverse the tree using a pre-order approach. And what you do is that you start from the root, you add 1. If there is a left subtree, you go left, which there is here, you add 2, and then you cover the right subtree. So basically 1, 2, 3 is the correct thing here. And then you want to do example number 2. Let me clear this stuff here. I hope you understood what I was talking about. And when you want to do here, note that because there is no left subtree here, in the input, we have a null. But you start again from the root, you add 1. There is no left subtree, so you go to right. You get here, you add 2. And then here, basically this is your new root. You need to cover left subtree first. You come here, and then you cover number 3. That's why you get 1, 2, 3. So now we get to the last example, example number 3, for the pre-order case. And then I just added this procedure here as a reminder. You start from the root, you cover left subtree, LST, and then you cover right subtree. And for this example, we want to know what is the pre-order traversal, right? We have an array of output. You start from the root. You add 1 here. Then you're supposed to cover the whole left subtree before you move to the right subtree, right? So we come here. Oops. We add 2, right? And now basically 2 is our new root, right? 2 is our new root. We need to cover, let me change colors. You need to cover the left subtree of 2, everything about the left subtree of 2 before you move to the right subtree of 2. Therefore, you add 4 here, you cover this one. And then when you get to the leaf, you go up. You come to 2. Have you covered the right subtree? No. Now you come down to the right subtree up to. And then you add 5. Now your 5 is your new root. You go left, you add 7. When you come to a leaf, you go back to the root. Is there a right subtree? Yes, there is. There you go, and you cover it. Now you have 8. Now what you've done is that you cover the whole left subtree of the main root, the actual root of the tree. Now what you do, let me change color. You go to right subtree. You need to cover the whole thing here now. When you go right, you have this one. Therefore, you add 3 to the list. And then you come down. There is no left. Left is null here. So you come down, you add 6. And once you're at 6, 6 is basically your new root. What do you have? You need to cover left subtree first. You come here, you add 9. Now you've covered the whole right subtree. Basically, your output is going to be 1, 2, 4, 5, 7, 8, 3, 6, 9. I hope I haven't made any mistake. But the whole idea is that whatever node you're at, let's say you are at this node, right? You need to cover the left subtree, if there is a left subtree first. And once you get to the leaf, you move back basically to the root, and then you go and you cover the right subtree. And you do this either iteratively or recursively, as I'm going to talk about later. So let's do an actual coding problem. For this, I'm going to do an easy problem. It's a Leetcode 144. Let me change color. So it's like a binary tree preorder traversal, as you can see here. You're given a root and root of a binary tree. If you don't know what is binary tree, just Google. It's a tree which has for each node maximum of 2 channels. So it's like something like this. And you're required to return the preorder traversal of the nodes. We talked about a couple of 3 examples actually before. But as an additional example, you can see here you're given this, and the preorder traversal, as we talked about, is 1, 2, 3. And on a solution section, note that you're given a 3-node class. If you don't know what is a class in Python, just Google. And I honestly think that if you want to do Leetcode, or if you want to be a good programmer, learn about class. Just spend couple of hours, learn about class, what it is exactly, and where it's useful and where it's not useful, and why there are classes out there, why they exist. So a 3-node class is a class which has a value, a left node and a right node. Basically, you have a node, right node or left node. It can be null or none, as it is by default. You can see here its default is none, and the default value is 0. And each node, so for example this node, has a value for itself, and it has a left node and a right node. And what I'm going to do here, I'm going to talk about 2 approaches. One, recursive, and next, iterative approach. Note that generally recursive is a little bit easier than iterative. That's why I'm going to talk about it first. All right, let's first talk about a recursive solution. I hope you know what is a recursive solution, but if you're not, please make sure that you understand what is a recursive solution by Googling, and there are a lot of problems on Leetcode and on the internet that can be solved using a recursive approach. I talked about the first part here. This is a 3-node class, which basically is you have a node, you have left and right subtree, or left and right, basically children. And the way I'm going to write the code here, as you can see here, I'm going to basically use the class approach. I'm going to define 2 functions within the class solution. and I initiate an empty list. As you can see here, the self-res, res stands for results, and I'm gonna return that self-res finally as my output. But using this middle function, the self-traverse route, which basically is a function called traverse, and you can see the function here I'm going to talk about in a minute, which accepts the route and then does some stuff, updates the res, and finally I return the res in this line, as you can see here. But the main part of the code is the traverse function. This function basically. This function is part of the class solution. That's why there is a self here, and then it accepts the route. The reason that we don't need to add res here, like having something like this, is that because it's part of the class. If you don't know why I don't have res here, but res gets updated, please make sure that you understand how classes work. So this is the function that does the updating for us. What happens here is that you have a route. Let me start by an example. Let's say we have 1, 2, the example that we talked about before. Let's say we have this example. What should we return? We're supposed to return 1, 2, 3, right? It means that we start from here. We're supposed to move here and then add 2, and then we're supposed to move here and add 3, and then it will give us 1, 2, 3. And this is what exactly the traverse function does. The traverse function, what it does is that it first checks whether route exists. If the route is none, it stops. It doesn't do anything. But if there is a route, meaning that as a first step, if the route that you gave, which basically is this 1 that we have here, if it exists, it goes and adds the value of the route to the self-res, which is basically our output, right? So that value gets added. What happens so far is that we have 1 here. We need to somehow add 2 and 3. What would we do? The next thing is that if you remember in a solution, what the procedure for preorder was root, left subtree, and then right subtree, right? So we need to consider left subtree here. But for example, for the example that we're considering here, this tree, there is no left subtree. Left subtree is null. But in a recursive approach, what happens is that we call this the same function using the root left, right? What happens now? If we call the same function using root left, meaning the root left is null, what happens is that this line does not get passed, and we're going to return, let's say, none here, meaning that nothing happens for the case that we're considering here for the example. And what's the next line? The next line is that we do the same thing. We call the function self.traverse, right? But this time with root right. What is root right? Root right is this, root right is this 2 here. When we call this function with root right, let me expand this function. What happens is that we are doing self traverse root right. What is root right? Is basically 2, 3. This is what we're doing. And what happens if we call this function? It goes and starts the traverse function again. What's the first step in the traverse function? Note that this is now our new root, correct? What happens is it adds the root value to self.res, meaning that this one gets updated here, and now 2 is added. Now 2 is our new root. What is the procedure for preorder? After the root, we need to check and take care of the left suborder, right? What happens here is that after we add the, let me change color again. After we add the 2 at this line, we go and check the left subtree at this line. This line gets called, the second line for the left subtree, and then that's where 3 is gonna be added. And that's all. We don't need anything else. There is no other node, and then you got it. We have the whole thing added, and therefore we have our output. And this was, as you know, was just an example. This approach works for any tree or the examples we talked about before because it's generic, right? For each tree, if you give the function the root, it's going to check the root, whether the root exists or not. If it exists, it adds the root value, as should be. Next, it takes care of the left subtree, and then it takes care of the right subtree. Note that we talked about this. It takes care of the left subtree, meaning that once it's gone into this line or this function, once this line is called and this function is called again, it's going to go to the left subtree. It does everything for the left subtree first before moving to line C, before moving to this line. Therefore, once you have your root gets added, it does everything for the left subtree before moving to the right subtree. Does that make sense? That's preorder, right? There, you have it. Next, we move to the iterative approach or iterative solution. I hope you understood the recursive one, and let me know if anything was unclear. I would be happy to explain it in more detail. I hope I haven't been repeating myself too much in a recursive part. Let's move on. For iterative approach, the high level idea is the same. It doesn't matter you do it recursively or iteratively. You're doing the preorder and the approach is the same. However, you do it in a different way to do it iteratively, right? And just as a general, tip or out of experience, whenever I hear iterative, I'll think about while and I'll think about stack. And in pretty much all the iterative examples that I've solved, I've used these two. So maybe it comes handy for you as well. This part we covered before, so we don't need to waste any time on this. And here, instead of doing your recursive approach, we're going to focus on the iterative. And the way we do is that we start from the root. Here it is. You check the root. If there is no root, it means that you don't have anything, right? You have an empty tree. You return an empty list. Then you start from the root. If there is a root, you add the root to the stack and you initiate a res function, a res list, basically a result list, which you're going to return at the end here. So you start the while, and what happens is that, let me draw that famous example of ours. So it means in this line, you're basically doing a while stack, right? It means that while there is something, the stack keep running. And while stack is empty, done, and return res as an output. However, while you are in the stack, do something. We added root to the stack. So at least the stack should be called once, except for the fact that this line gets activated and we return none. If we don't do that, if we pass this line and we come here, we have root in the stack and we need to do the stack. We need to do the while loop at least once. What happens is that we pop the last element of stack, meaning that we pop it and we call it root. What do we do now? We are looking at our root. We add it to the res, right? This is what we do. Whatever node we are looking at right now, this is our new root. And in a preorder approach, we start from the root, we go left, and then we go right, correct? Therefore, we add root value to the res. Now, here, based on this example, we have 1 added. Now, we're supposed to add 2, and then 3, right? Here it goes. We check the right subtree. You may ask, we are doing the preorder, why we are checking the right subtree, right? And you're correct. We are checking the right subtree first because we are appending to the stack, meaning that when you do append, right, you add from this side when appending, and then you add A, B, C. You append A, B, C. And when you're gonna pop the stack, pop something from the stack later, what happens is that the rightmost element gets popped first, right? And what do you want in a preorder? You want the rightmost being the left subtree. That's why first you check the right subtree, which means that it goes down into the stack, and then you check the right subtree. You check the left subtree, excuse me. First right, then left, which means that this gonna be, oops, something happened. Excuse me. It means this C is gonna be your left, this B is your right. And when you're gonna pop, C pops first, meaning that left pops first, you deal with left subtree, and then you move on to right subtree. So here, you have a right, basically, root right gets activated, you add this 2 to your stack, and then you come here, you don't have any left subtree, nothing happens. Then you go to the second iteration of the while. Now the root is 2, right? Basically your right subtree of your initial root. Now 2 is gonna get added to res, meaning that this is updated to 2, and then you go again for the check. Do you have, let me clean this up a little bit so that we can communicate more effectively. Now where are you? You're here, right? You're at 2. You come into the check. Do you have a right subtree? The right subtree is none. Therefore, this line doesn't get activated, but there is a left subtree 3. You add this to the stack. Let me tell you what is the stack right now. A stack is what? The only thing in the stack is 3, because initially root was in the stack, you popped it here, and then you added the right in the second iteration, and then you popped it again. When you popped it, it got added here, if you remember, and now you're adding 3. In the last iteration, when you come here to basically pop the root and add the root to the res, you're looking at 3, and that's where the 3 gets added. And then when you're coming here after the third iteration, this one doesn't get activated, this one doesn't get activated, therefore you jump out of the loop, the while loop, and you come here, return the res, which is what we need. And done. That's your code. And just to explain a little bit more, what you do is that you add the root. If there is a root, you add the root to the stack. You pop the root, add the root to the res, check the right, check the left. If right exists, add the right. If left exists, add the left. What happens here? Right gets added first, and then left gets added second. And when you want to pop, left pops first. That's what you need for preorder. And then finally, you turn the res. All right, I hope you enjoy it. Let me know if there is anything unclear.